Hey everyone, this is meteorologist Ben Price at the National Weather Service in Springfield, and welcome back to another Weather Unlocked session. This is video 31, and we are going to be talking about lake effect snow. This is a type of weather phenomenon that you may or may not be familiar with based on where you live, but even then it's sometimes known to drop an absurd amount of snow on a very small area. It's in the news a lot, so you may be familiar with this phenomenon. So we're going to go through exactly what it is and what causes it to form. So what exactly is lake effect snow? Well, the short, long answer is that lake effect snow forms when cold, below freezing air passes over a lake's warmer waters. This causes some lake water to evaporate and warm the air. Then the moist air moves away from the lake. After cooling, the air dumps its moisture on the ground, potentially becoming snow. These bands are quite narrow. As you can see in this animation here, these are the lake effect snow bands. They look like cloud streets that come off of the lake as the wind blows that warm air off of the lake and condenses into snow. They're relatively narrow, and so it could be clear in one spot, as this image shows, but then just a ton of snow just a small distance away where these clouds are. Now, don't worry if that short answer wasn't really short and had a lot of information. We're going to be jumping into all these specifics in this video so that you can have a better understanding of how lake effect snow forms and how it happens. But before we move into the nitty-gritty, how do the lakes even produce such snowfall anyways? Like, why do the lakes do this? Well, the short answer is that water is able to retain heat longer than the air or ground. More specifically, it takes more time for the water's temperature to change to its surroundings. It transfers heat much slower than its surroundings. So here's an example to better understand this concept. You've got a glass of ice-cold water on a hot summer day. At the same time, you also brought out a normal sheet of metal, or you can maybe think of it like the hood of your car. Now, as the sun heats these items up, of course the ice is going to melt as the water warms, until all of the ice is melted. Now think about how long it takes for ice to completely melt in the hot summer day. Once it's melted, the water isn't necessarily hot, is it? It could still be lukewarm, but at this time, that sheet of metal, or the hood of the trunk, is probably pretty hot to the touch. The water takes a lot longer to warm up, and is not as warm as the sheet of metal that you touch. This works backwards too. If it got really cold out, it wouldn't take that long for the sheet of metal to freeze, to feel ice cold, but it would take quite a bit longer for that cup of water to freeze up. So now that you've got that concept done, we've set the scene for the lakes. They've spent all this time warming up during the summer that now when winter begins, the water takes a lot longer to cool down than the surrounding air and ground. So it will be warmer than the air. We know that warm air rises because it is lighter than cold air. So when cold air sweeps across the lake, it evaporates some of the surface water, which is warmer than the air, so it rises, then cools and condenses into clouds and snow, and then that snow gets blown onto the land by the wind. So here's a real-world example to put that diagram to use. And if you're thinking the clouds kind of look like thunderstorm clouds in this picture, well, it's because lake effect snow actually forms in the same sort of way as thunderstorms, and that's warm, moist air rising because it's lighter than the cooler air around it, then condensing and falling as precipitation. In a thunderstorm's case, that precipitation is rain, but in this case, that's snow. So the lake is warmer than the air above and the ground next to it. When the cold air sweeps across the lake, the warm surface water evaporates and rises. As it rises, it cools with the cold air around it and condenses into clouds and falls as snow. So that's how you get lake effect snow in a nutshell. Now that we've got the basics out of the way, let's dive a little bit deeper. So there are two types of lake effect snow bands that form. There's long lake axis parallel bands that are these single bands that span the whole long side of the lake. As the name implies, the band is parallel to the long side of the lake. So it's parallel to this long lake here, pretty much. It's named after its name. And then there's wind parallel bands that are smaller, but there are more of them. And again, as the name implies, these are parallel to the wind direction. So the wind will be blowing this way, and that's what's parallel to those wind bands. So let's take an even closer look at how each of these form. The long lake axis parallel bands, they form in relatively weaker wind conditions. If you have too strong of a wind, that delicate band will tear apart. And just as with any lake effect snow event, the lake water will be warmer than the surrounding air. Now, something important I should note, this cannot happen if the lake is frozen. If the lake is frozen, well, it'll be cold and there's no water to evaporate, so lake effect snow wouldn't happen if it was frozen. So lake effect snow events generally happen in the beginning of winter before the lakes have time to freeze over. Anyways, the warm lake water that is shown here is going to end up rising because it's lighter than the air around it. So if that air rises, it's leaving a quote-unquote void underneath. Not really a void, but something's got to fill in that space. So air has to fill it in from somewhere. So air moves in from both sides of the lake to fill this gap. This creates convergence and upward motion in the middle of the lake and forms that one long band across the middle of the lake. If the wind direction is just right, it will push the band onshore at the end of the lake. In this example, the star is Buffalo, New York. It's the most notorious city for lake effect snow, exactly because of these snow bands. Because there's so much water that the air goes over before reaching the land, these long lake axis parallel bands generally produce more snow than wind parallel bands. So that brings us to wind parallel bands. These form in relatively stronger wind conditions, although again, not too much, otherwise they'll tear apart, but relatively stronger than long lake axis bands. The stronger winds organize these bands better than the long lake axis parallel bands do, such that you get these organized circulations. So there's upward motion and then there's downward motion. Upward motion, downward motion. It's like a circulation in the vertical. The bands of snow occur where there's upward motion here, and the air spreads out and sinks, so there's no clouds in the areas of downward motion. This produces these cloud streets that you can see in the image on the right. So each of these band of clouds is one of these upward motion bands, and then in the middle where it's clear, that's where there's sinking air. So it creates these circulation bands. Because of the thinner nature of these bands, and because they form after the short edge of the lake, so this is Lake Superior here, this would be the long edge. Since they're coming off the short edge here, they generally produce less snow than the long lake axis parallel bands. But don't get caught off guard, because they can still persist for hours and still produce a lot of snow. And by a lot, I mean a lot. Here's just an example of a snow forecast for lake effect snow. Greater than 36 inches over a 3 to 4 day period in Buffalo, New York. And you probably see Buffalo in the news a lot for these types of events. Buffalo received a storm total of over 50 inches one time. These can create impacts in very small areas, including great difficulty clearing roads, parking lots, and driveways, making it difficult to drive and leave homes and businesses. And it also adds a lot of weight onto houses and businesses. And not to mention, that's a lot of weight to shovel. So, the video is almost over, and you may be wondering, what does this all have to do with Southwest Missouri? The Great Lakes aren't even close to here. Well, you're right, but lake effect snow does happen in the Missouri Ozarks. It's just not as much snow or as impactful. And it has to be very cold since the lakes are smaller here, but when it does get that cold, you can see lake effect bands coming off lakes like Stockton Lake, Lake of the Ozarks, Table Rock Lake, and more. These can produce anywhere from a light dusting up to an inch of snow. On the right is a tweet. One of our meteorologists has a great in-depth thread on this. If you're looking for even more education on the topic, you can go to the link that's on the bottom right, or you can just search it up on the search function on X or Twitter. Now to let you think about what you've learned, I'll leave a question for you. What type of lake effect snow bands are shown in the GIF to the right? You can see the snow bands coming off. This is Stockton Lake here, and it comes off here of Table Rock Lake as well, Lake of the Ozarks. So these are lake effect snow bands coming off of those lakes. What kind of lake effect snow bands are they? I'll let you answer that on your own. But that's all. Thanks for listening to this session of Weather Unlocked. I hope you were able to learn something today about lake effect snow, and make sure to follow us on socials or on our website for any weather information you may be seeking out. And stay tuned for the next section, which will be on layers of the atmosphere. Bye now.